So I was talking about this book. This book is good if you want, but वैसे ज़रूरत नहीं है. It is better than Savindra Singh Climatology. So we did, I'm quickly revising, we did temperature inversion yesterday. There are three types: adiabatic, जहाँ पे there is a movement of air; non-adiabatic, when there is no movement of air; and there is mechanical inversion. और in the terms of, अगर extra किसी को लिखना है, in the terms of the height, there are two kinds of inversion: surface. Yeah, no, don't write surface because surface inversion is one kind of an adiabatic inversion. Ground inversion and upper air inversion. Upper air inversion is generally mechanical. Ground inversion can be either adiabatic or non-adiabatic. ये ऐसे भी लिख सकते हो आप आंसर. Adiabatic inversion is of three types. Frontal, हमने देखा कहाँ पे, जहाँ पे there is a trade winds and westerlies. Then frontal is also known as cyclonic. Surface inversion, which is due to the ocean currents. Getting it? जो आज का एक क्वेश्चन है, वाटर मासेस एंड ओशन करंट्स का इम्पैक्ट, जीएस वाला नहीं लिख पाएगा. अंडरस्टैंडिंग? इट इज़ वेरी गुड क्वेश्चन फॉर द ऑप्शनल स्टूडेंट्स. जीएस वाला नहीं लिख पाएगा क्योंकि वो ओशन करंट के आगे नहीं बढ़ता. वाटर मासेस मतलब क्या? वेव्स, टाइड्स, सैलिनिटी, टेम्परेचर, upwelling, downwelling. How does it impact the marine biodiversity? और नॉर्थ-वेस्ट इंडिया में what are the agro processing industries? Look 3 years back in your past year question. Malwa plains of Punjab में what is the scope of agro processing industries? As it is question है, Malwa plains and northwest India is the same, the scope of agro processing industries. और बाकी questions were very easy. Then we have the third kind of inversion, that is the valley inversion. Non-advectional is thermal and ground inversion, and mechanical is either due to subsidence of air at dry adiabatic lapse rate or the convective uplift of an air. Fine, when the air is goes up convectively, and then either when it comes down at the dry adiabatic lapse rate. Clear? Coming to the quick understanding, coming to what are known as the pressure belts of the world. So we have some pressure belts of the world which is known as the equatorial low pressure belt between 5 degree north and 5 degree south. Then we have the subtropical high pressure belt or the horse latitude between 30 to 35 degree north and 30 to 35 degree south. Then we have the subpolar low pressure belt between 60 to 65 degree north and 60 to 65 degree south. And then we have the polar high pressure belt. So 30 to 35 degree north, 60 to 65 degree north, 90 degree north, 30 to 35 degrees south, 60 to 65 degrees south, and 90 degree to the south. This equatorial low pressure belt is known as the belt of doldrums or calm conditions. This equatorial low pressure belt is also known as ITCZ. It is an example of thermally induced pressure belt. It is an example of thermally induced pressure belt. Fine. This pressure belt is dynamically induced high pressure belt due to subsidence of air. And इसको हम कहेंगे horse latitudes. This pressure belt is the belt of fronts, and this pressure belt is the again a high pressure belt due to extremely cold climate. So the air that rises from the equator, side view, due to the tropopause here, वो उसके आगे नहीं जा सकती, it goes into some other direction. Ideally this air should go and settle over the poles, but it becomes very cold, उसका density increases and therefore it settles downwards, resulting into formation of an polar high pressure belt, subtropical high pressure belt. फिर it starts flowing towards the equator on the surface as trade winds. In the northern hemisphere, it is going to get deflected to the right, and in the southern hemisphere, it is going to get deflected to the left, and it starts flowing as the trade winds, yeah, easterlies. Then they both join at this, and because of the low pressure, ये ऊपर उठती है. We call this as a ITCZ. Fine. Similarly, air from this region, because of the descent of the air here, यहाँ से नीचे आएगी air from this region starts flowing towards the polar, subpolar regions. यहाँ पे आके गर्म होती है, so it starts rising upwards and it goes back, completes the another cell, and again it settles down from here, starts flowing on the surface as easterlies because they will get deflected to the left, and यहाँ पे आके rise होती है and it completes a circle. Because these two are high pressure belts, जहाँ पे air is forced to descend, automatically बीच में there is a low pressure belt, and therefore warm westerly winds will go from this place to this place. That is, they will get deflected to the right, and ऐसा लगता है west to east जा रही है. They will get deflected to the left in southern hemisphere, ऐसा लगता है west to east जा रही है. Therefore, we will call them as westerlies. It will rise up, and then it will come and settle down. It will rise up due to fronts, and it will come and settle down. यहाँ पे there is a jet stream, यहाँ पे there is a jet stream, यहाँ पे there is a jet stream, यहाँ पे there is a jet stream. This model which I have drawn is known as tricellular meridional circulation of winds. Yeah, it is known as Hadley-Farrell polar cell. Clear with this? Clear with the wind pattern? Any doubts here? धीरे धीरे और कवर हो जाएगा why it is moving here, कैसे जा रही है winds, but this is what is the overall understanding of the subject on the winds. यहाँ तक clear है सब कुछ? Should I proceed? So tell me, question आता है, write a short note on Hadley cell. क्या लिखोगे? Easterlies या westerlies? Question आता है on the Hadley cell. Which is Hadley cell? This is Hadley cell. This is Farrell cell. वैसे आएगा नहीं इतना इजी क्वेश्चन. This is polar cell. Tell me what you are going to write. Write a short note on Hadley cell. Start करो, क्यों हवा ऊपर जा रही है. फिर सबसे पहले इंट्रोडक्शन में Hadley cell कहाँ पे है? Between equator to the 35 degrees. That is, can I say the wind pattern and the air circulation. Wind pattern लिखोगे या air circulation लिखोगे? The air circulation in the tropics, because event तो सिर्फ ये है. The air circulation in the tropics in the form of both convection and advection is known as, was discovered by Sir Hadley, and therefore it is known as Hadley cell. This was against the idea of single cell model. कल का lecture single cell model. ये हवा ऊपर जाएगी and ये settle होगी and there will be winds. It was against the idea of the single cell model which was propounded before Sir Hadley. In this, as the equatorial regions receive insolation throughout the year, and most of the insolation is ये है चीज़ें why we have studied the other topics, and because the sun rays are more or less vertical throughout the year, therefore this region is thermally induced low pressure belt. Thermally induced means due to heating. As a result of this, air from the equator rises upwards due to the convectional currents. This rise of the air from the equator is a daily phenomena which results into 4 o'clock rainfall in the equator. This air after rising upwards gets bifurcated into two parts and goes towards the poles. The air which moves polewards becomes colder and hence denser. This denser air is forced to sink between 30 to 35 degree latitudes, resulting into formation of subtropical high pressure belt. The air which sinks then starts flowing as trade winds, and due to the Coriolis force, they get deflected to the right and left, and hence they are known as easterlies, because they going from east to west. These winds after coming near the equator, they converge and rise up, and hence the equatorial low pressure belt is also known as ITCZ. Getting it? Asan hai? Fine. Same with feral cell. Same with polar cell. मैं लिखाऊंगा, don't worry. I'll make you write this. थोड़ा technical language में, but understanding what is the cell. So खुद के language में भी लिख सकते हो, even if you are not studied. So quickly 2-3 points regarding the pressure belts. The earth is divided into different pressure belts, and this pressure belts are formed due to thermal differences or temperature differences, comma rotation of the earth, as well as the Coriolis force. As well as the Coriolis force. The general distribution of the pressure belts is shown with isobars. General distribution of the pressure belts is shown with the help of isobars. And there is an alternating pattern of high and low pressure belts. High and low pressure belts, giving rise to number three, thermally induced pressure belts. Three thermally induced pressure belts. कौन से है 3 thermally induced? 2 polar high pressure belt and 1 equatorial low pressure belt, and 4 dynamically induced pressure belts. 4 dynamically induced pressure belts. Three thermally induced pressure belts and 4 dynamically induced pressure belts. Understanding? So what are the 4 dynamically induced? 2 subtropical high pressure belt, एक northern hemisphere का, एक southern hemisphere का. 2 subpolar low pressure belt, एक northern hemisphere का, एक southern hemisphere का. These are the 4 dynamically induced pressure belt. कुछ नहीं, as it is GS का है, सिर्फ language देखो. Just see the way we approach in optional. बता दिया फर्स्ट स्टेटमेंट में कोरियोलिस फोर्स भी है, बता दिया फर्स्ट स्टेटमेंट में रोटेशन ऑफ द अर्थ भी है, बता दिया फर्स्ट स्टेटमेंट में थर्मल टेम्परेचर डिफरेंसेस भी है. फाइन. बता दिया स्पेसिफिकली कितने प्रेशर बेल्ट्स है, उसमें से कितने थर्मली इंड्यूस्ड है, कितने डायनेमिकली इंड्यूस्ड है. फाइन. सो जब भी आओगे आएगा थोड़ा ऐसे लिखना टेक्निकली. डोंट राइट वही जीएस का आंसर, अदरवाइज आगे कुछ भी नहीं है. जीएस का आंसर जीएस जैसे मार्क्स मिलेंगे. फाइन. आज का पेपर जो है वाटर करंट्स एंड ओशन करंट्स एंड वाटर मासेस का, किस कोई भी लिखेगा मिक्सिंग, कोई लिखेगा अपवेलिंग, कोई लिखेगा कि न्यूट्रिएंट एक्सचेंज, और सब उसको अच्छे मार्क्स मिलेंगे. बट वही आंसर अगर सेम कल मतलब ऑप्शनल में आता है और आपने यही लिखा, मेंशन नहीं किया डाउन वेलिंग, मेंशन नहीं किया ग्रोथ ऑफ कोरल्स, मेंशन नहीं किया न्यूट्रिएंट एक्सचेंज, you will not get the marks. Fine. There has to be bit technical. You have to mention maybe Ekman spiral in this. Water masses are moved by the Ekman spiral. Getting it? And you can draw this diagram. No need of adding these points. ये सब मत लिखो. Can I continue? इक्वेटोरियल लो प्रेशर बेल्ट, क्या क्या लिखोगे इसमें? डोल्ड्रम्स, ITCZ, thermally induced, some extra things which should reflect in the optional answer, which shows that you understand the subject more. So what are these extra things other than GS? One, कि the extension of the equatorial low pressure belt is more prominent in the northern hemisphere than the southern hemisphere, because oceanography याद रखो, the northern oceans are hotter than the southern oceans. Why? Because they are more connected to the land. ये आना ही चाहिए आंसर में. Second, ITCZ is imaginarily connected to the sun. मतलब sun जैसे shift होगा वैसे the ITCZ will shift to the north and south. And इसीलिए ITCZ extends to the monsoon lands of Asia during the summer solstice. ये सब extra points है. I will dictate this in the points. Can I continue? The diagram is wrong. इसका height should go on decreasing. या फिर ये बनाओ ही मत. अगर बना रहे हो तो make sure that height goes on decreasing. Remember, this is troposphere, tropopause. उसके बाद this is the stratosphere. उसके बाद this is the mesosphere. Height of the tropopause is only 8 kilometers here. It is 18 kilometers. It is 12 kilometers. Height goes on decreasing. ये मत बनाओ. Don't make it. It will बहुत खिचड़ी लगेगी फिर. Should I continue? Doldrums or equatorial low pressure belt. Tell me, thermally induced or dynamically induced? Thermally induced. So first point, thermally induced, because of maximum insolation, is available throughout the year in the equatorial regions. Is available throughout the year in the equatorial regions. Hence, the pressure, hence the average pressure is less than 1013 millibars. Is less than 1013 millibars. ये है एवरेज प्रेशर 1013 मिलीबार्स या 1035 मिलीबार्स, ये हम पढ़ते ही है जीएस में भी. एवरेज सी लेवल प्रेशर इज 1013 to 1035. आपको सिर्फ बताना है कि इट इज लेस देन 1013 मिलीबार्स. because the heated air expands, heated air expands, becomes lighter and rises up. Rises up in the form of convectional currents. In the form of convectional currents, giving huge amount of latent energy, मतलब latent heat, giving huge amount of latent heat. जैसे ही एयर जाएगी लेटेंट हीट. एंड इक्वेटोरियल रीजन्स में लैंड मास कम है. वेगनर की थियरी याद रखो, पोलर फ्लीटिंग फोर्स. देयर वाज सम कंट्रोवर्सी की पोलर फ्लीटिंग फोर्स क्यों. आई टोल्ड यू रोटेशन ऑफ द अर्थ. आई डोंट नो whether you remember it or not. Rotation of the earth, इसने कहा था वैज्ञानिक ने कि इट इज रोटेशन ऑफ द अर्थ गिव्स राइज टू द पोलर फ्लिटिंग फोर्स। हमने उसका कंट्रोवर्सी भी लिखा था कि इफ रोटेशन ऑफ द अर्थ इज रिस्पॉन्सिबल फॉर द पोलर फ्लिटिंग फोर्स देन ऑल द कॉन्टिनेंट शुड बी नियर द इक्वेटर, बिकॉज सबसे ज़्यादा इट शुड बी नियर द इक्वेटर, बट वैसा नहीं है। मोस्ट ऑफ द कॉन्टिनेंट्स आर अवे फ्रॉम द इक्वेटर। इक्वेटर रीजन पे लैंड मास बहुत कम है, फाइन। सो गिविंग राइज टू latent heat or latent energy, making this region warm and moist, making this region warm and moist, making this region warm and moist. Next point, the equatorial low pressure trough. Now why the word is trough? Trough means the belt of low pressure, जहाँ से हवा ऊपर जा रही है. What is meaning, English meaning of word trough? Trough means जो depression है, fine. So equator पे हम trough क्यों कहते हैं? Because sides पे there is a high pressure and center में over the equator there is a low pressure. So therefore we use the word trough. The equatorial low pressure trough extends more to the north, to the north. याद रखना oceanography, northern hemisphere is more hot, extends more to the north, and this trough is tied with sun. Trough is tied with position of sun. Tied with the position of sun, and hence it shifts either northwards or southwards. It shifts either northwards or southwards during the summers and winters respectively. During the summers and winters respectively. During the summers and the winters respectively, giving rise to monsoon type of climate. Giving rise to the monsoon type of climate. ये डायग्राम ड्रॉ करने की जरूरत नहीं, I'm just showing you. This is the equator, this is the tropic of Cancer, this is the tropic of Capricorn. अब when the sun is over the tropic of Cancer in the month of June, ये पूरा ITCZ ऐसे shift होगा north की तरफ. So this is the June position of ITCZ. And when the sun is in the southern hemisphere in the month of December, ये पूरा ITCZ will shift southwards. This is the Jan ITCZ, and you can see Australia में बीच में ऊपर चला गया है. Reason is, remember, oceanography, cold ocean currents. Fine, so this region does not become very hot. यहाँ पे नीचे आया है, remember oceanography, warm ocean currents. Getting it? So this is what is the, this is the ITCZ का original position. This is the month in the June, and so यहाँ पे when it is there, low pressure is over India. So therefore winds आती है towards India in the form of southwest monsoon winds. And when the ITCZ is over Australia, अभी recently जो हो रहा है, winds are going towards ITCZ in the northeast monsoon winds. Coriolis force right को deflect करती है, southern hemisphere में left को deflect करती है. Coriolis force left को deflect कर रही है, northern hemisphere में right को deflect कर रही है. This is what is monsoon. Fine. यहाँ से भी monsoon, यहाँ से भी मानसून. एंड रिमेंबर, जब अल नीनो होता है तो ये पार्ट वीक हो जाता है, इसलिए ड्रॉट्स इन इंडिया, दिस पार्ट बिकम्स वीक. जब नॉर्मल कंडीशन है, दिस इज हाई प्रेशर, व्हेन अल नीनो इज देयर, इवन दिस इज अ लो प्रेशर. सो ये गायब हो जाता है, जो सेंटर की 2 लाइन्स है ये गायब हो जाएगी. एंड देयरफॉर वी से द मानसून हैज बिकम वीक. गेटिंग इट? नेक्स्ट point. It is a zone of convergence of trade winds. It is a zone of convergence of the trade winds. And hence known as ITCZ. But the winds in this zone, are very light, and variable, Therefore, this region is known as belt of doldrums. This region is known as the belt of doldrums. This region is known as the belt of doldrums. Known as the belt of doldrums. In the belt of doldrums, during the summer season, light winds blow from west to east. Light winds blow from west to east. Light winds blow from west to east, known as we will do this separately, equatorial westerlies. Known as equatorial westerlies. नहीं ना, ये एक्सेप्शन है, इसलिए मैंने कहा ये अलग से पढ़ेंगे. ये एक्सेप्शंस है, इक्वेटोरियल वेस्टर्लीज, वेस्ट टू ईस्ट, ईस्ट का इक्वेटोरियल वेस्टर्ली. ये सिर्फ मानसून समय के समय चलती है एंड ये एक्सेप्शंस है. फाइन, ये जनरलाइजेशन नहीं है, ये ऑब्वियसली जीएस में नहीं पढ़ाया है, कोई नहीं पढ़ाएगा, किसी भी क्लास में नहीं पढ़ाएंगे इक्वेटोरियल वेस्टर्लीज. इक्वेटोरियल वेस्टर्लीज इज properly optional wala topic. It was discovered by Trevartha. These are light winds which blow from Indo-Pacific doldrum to the Asiatic doldrums. These are the winds when, understand, likho kuch bhi mat, these are the winds when the normal monsoon winds cross the equator. Sometimes some of the winds turn from west to east, और इनको हम कहेंगे equatorial westerlies. They are more or less related to the counter equatorial current, which is generated, which changes uska direction. Fine, equatorial westerlies, counter equatorial current. And counter equatorial current हमेशा नहीं होता है इंडियन ओशन में, इसलिए हमने लिखा sometimes. नहीं तो जनरल क्या है सर्कुलेशन, ईस्ट टू वेस्ट, बट यहाँ पे in the monsoon lands there is west to east. These are what are the equatorial westerlies. कभी कभी equatorial westerlies become so large. Westerlies मतलब क्या है? The wind is blowing from west to east. They become so large that they come to India as southwest monsoon winds. Equatorial westerlies मतलब a small part is southwest monsoon winds. West to east आ रही है. Fine, that is the equatorial westerlies. It has to do with the shifting of ITCZ. Next. This belt of doldrums, is more pronounced in Indian Ocean, is more pronounced in the Indian Ocean because of dominance of the warm water in the North Indian Ocean, because of the dominance of warm waters in the North Indian Ocean. This warm waters in the North Indian Ocean. Understanding there is no cold current. This zone of dominance of doldrums is known as Indo-Pacific doldrum region. Indo-Pacific doldrum region, which extends from west of Africa to the western coast of Central America. मतलब ये पूरे रीजन में there is a dominance of doldrums, which is known as an Indo-Pacific doldrum, west of Africa to the western coast of Central America. अब थोड़ा आगे का समझो चीजें. Everything, because in the climate, unlike geomorphology, is related. Sometimes during the summer season, this Indo-Pacific doldrum में there is a variation in the temperatures. The western part of this Indo-Pacific doldrum becomes very, very warm. The western part of this Indo-Pacific doldrum becomes very, very warm in the summer season, and इसी को हम कहते हैं positive Indian Ocean dipole. Why it is positive? Because if this is warm, then there will be more rainfall in India. जितना ज़्यादा ये western part is warm, उतना more evaporation. जितना more evaporation, उतना more winds from all these regions will be attracted towards this low pressure. They will become moist. और यहाँ पे आने के बाद वो देखेंगे कि this land mass is still more warmer, so they will be attracted towards India. Sometimes ये region थोड़ा ठंडा हो जाता है, and it is known as negative Indian Ocean dipole. During this time when there is a negative Indian Ocean dipole, यहाँ पे ये ठंडा है, बाकी का part गर्म है, so winds यहाँ से ऑस्ट्रेलिया की तरफ जाती है, and therefore it results into droughts in India. Understanding the relationship between the positive and negative Indian Ocean dipole. So अभी के लिए positive Indian Ocean dipole will give good rainfall or bad rainfall to India. Good rainfall. Negative Indian Ocean dipole, bad rainfall. Positive Indian Ocean dipole means Western Arabian Sea or Western Indian Ocean is warmer. Negative Indian Ocean dipole means Western Indian Ocean is cooler. If this is warm, winds come to India. If this is cool, winds go away from India. Fine? Wind will follow high pressure to low pressure. अगर ये cool है मतलब ये high pressure पे है. So कहाँ पे wind जाएगी? किसी और जगह. वो इंडिया की तरफ नहीं आएगी. Because ये पूरा Arabian Sea ठंडा होता है. And this is the more important factor which was discovered in 1997, which plays more important role than El Nino, La Nina. And remember, it has nothing to do with El Nino and La Nina. El Nino is an independent phenomenon of Southern Pacific. Indian Ocean dipole is an independent phenomenon of Central and Northern Indian Ocean. कोई relation ही नहीं है. Getting it? Understood doldrums? Fine? What is the doubt? Thanda means cold. Negative Indian Ocean dipole, this is cooler, means thanda. You have not seen the ad, thanda matlab Coca-Cola. So what is Coca-Cola? Is a cold drink, fine. And during the positive Indian Ocean dipole, this is warm. So when this is cool, this entire region is high pressure. So this is cool, somewhere else it is warm. So the winds, instead of coming to India, come here. When this is warm, winds come towards India, and they are deflected by Coriolis force towards India. As of now, just remember, positive Indian Ocean dipole, good monsoon, negative Indian Ocean dipole, droughts. Understood? Doldrums? So, understood, don't write at all like GS. आने दो ये सब टेक्निकल चीज़ें, इंडो पैसिफिक डोल्ट्रम और सब, एंड बाकी इक्वेटोरियल वेस्ट, सब ट्रॉपिकल हाई प्रेशर बेल्ट, सब ट्रॉपिकल हाई प्रेशर बेल्ट, सब पोलर लो प्रेशर बेल्ट, वो GSE है, उसमें कोई ज़्यादा ये नहीं. इसलिए लुक एट द पास्ट ईयर क्वेश्चंस, जितने भी क्वेश्चंस आए हैं ऑन द प्रेशर बेल्ट, इट इज़ ओनली ऑन डोल्ट्रम्स, because they expect that you write your answer in proper manner. And then we have the between 30 to 35 degree north and south of the equator, between 30 to 35 degree north and south of the equator, this region is dynamically induced high pressure belt, dynamically produced high pressure belt, because of sinking and settling of air from higher latitudes, higher altitude. From above, full stop. The air that rises over the equator starts flowing polewards as एंटी ट्रेड्स. ट्रेड विंड के अपोजिट डायरेक्शन में जो फ्लो कर रही है दैट इज एंटी ट्रेड, एज एंटी ट्रेड्स. आई विल कम टू द डायग्राम. दिस इज द डायरेक्शन ऑफ द ट्रेड विंड्स, दिस इज द डायरेक्शन ऑफ द एंटी ट्रेड विंड्स. फाइन. This, why the trade winds is getting deflected to the right hand side? Coriolis force, because it is coming in this way and it is going to get deflected to the right hand side. Ab anti trade is going in this manner, the way you are facing, right? Trade wind is coming in the way I am facing. Anti trade wind is facing you, the आपके direction में. So what is your right hand side? This. So anti trades के ऊपर भी Coriolis force act करेगा, एंड वो किस डायरेक्शन में जाएंगे? एग्जैक्टली अपोजिट टू द डायरेक्शन ऑफ द ट्रेड विंड्स, मतलब दिस वे. सो एंटी ट्रेड्स आर आल्सो नोन बाय डिफरेंट नेम एज और अपर एयर और अपर लेवल वेस्टर्लीज. अपर लेवल वेस्टर्लीज. एंड थोड़ा दिमाग लगाओ, यही अपर लेवल वेस्टर्ली बहुत ज़्यादा घूमेगा तो इट बिकम सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम. जेट स्ट्रीम ऑलवेज फ्लोज फ्रॉम वेस्ट टू ईस्ट. जिनका GS हुआ है एटलीस्ट दे विल बी एबल टू अंडरस्टैंड. सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम, इट स्टार्ट्स एज अ अपर लेवल वेस्टर्लीज. गेटिंग इट? Anti-trades or upper level westerlies, which due to cooling becomes denser and subsides. And subsides. Next point. The subtropical high pressure belt, is permanent over the oceans, but there is variation in the size of this belt. Over the land masses. Understanding this meaning कि high pressure belt सिर्फ permanent कहाँ पे है? Oceans पे. ऐसा equatorial low pressure belt पे नहीं था. It is a permanent belt. सिर्फ उसका पोजीशन शिफ्ट होता है. यहाँ पे ये डिसअपियर होता है. यहाँ पे लैंड्स पे कभी डिसअपियर होता है, कभी आता है. फॉर एग्जाम्पल राइट नाउ जो द लोकेशन वी आर 25 to 35 डिग्री लैटिट्यूड्स इज हॉर्स लैटिट्यूड्स, बट इंडिया के ऊपर इट डिसअपियर्स ड्यूरिंग द साउथ वेस्ट मानसून सीजन. फाइन, देयरफॉर वी गेट रेनफॉल. अदरवाइज हाई प्रेशर में देयर शुड नॉट बी रेनफॉल. गेटिंग इट? दिस इज व्हाट द मीनिंग ऑफ द स्टेटमेंट इज. It is permanent only over the oceans, and hence the ships used to throw away the horses. Ships, SHIPS ships, used to throw away the horses due to weak wind system. Full stop. Therefore, it is known as horse latitudes. Next point. The horse latitudes show variation in the eastern and western parts. Where the eastern parts are more humid. Can someone tell me why more humid? Western parts are more humid. Western parts of the oceans are more humid. Can someone tell me why? Warm ocean currents. अगर ये सब ट्रॉपिकल हाई प्रेशर बेल्ट में है, so यहाँ पे वार्म ओशन करंट्स है, ये ज़्यादा ह्यूमिड है वेस्टर्न पार्ट, एंड द ईस्टर्न पार्ट इज ड्राई क्योंकि कोल्ड ओशन करंट्स. एंड इसीलिए आपने जीएस में पढ़ा है द deserts are always located on the western part of the continents, क्योंकि where there are cold ocean currents. क्यों? क्योंकि eastern part of the oceans are dry. So I got confused myself. You me? The horse latitudes show variation in the eastern and western parts, where the western parts over the oceans are more humid. Bracket में due to warm ocean currents. and the eastern part over the oceans, eastern part over the oceans are cold and dry. Over the oceans are cold and dry due to cold currents, due to cold currents. Full stop. Hence, due to cold dry air masses, cold dry air mass, इसके ऊपर का एयर कैसे होगा? Cold and dry. Cold dry air mass. The western part of the continents, the western part of the continents in the subtropical high pressure belt, in the subtropical high pressure belt are the regions of deserts, are the regions of deserts. You already know this. Hurricanes, Sahara Desert. Sahara Desert के exactly opposite, Gulf of Mexico पे पास हमेशा there is an hurricane activity. This is the same state. Getting it? Clear? Last point, this zone is the zone of origin of, this zone is the zone of origin of trade winds and westerlies. This zone is the zone of origin of trade winds and westerlies. Clear? ऊपर जो जा रही है that is westerlies, जो नीचे आ रही है that is the trade winds. वो आएगी towards the equator and then it will form at ITCZ. Fine? Third, subpolar low pressure belt. It is located between 60 to 65 degree north and south. It is dynamically induced zone of convergence of warm westerlies and cold polar easterlies. Warm westerlies and cold polar easterlies. Next point, very very important, it has been your past year GS में paper में question also. This belt is continuous in the southern hemisphere. This belt is continuous in the southern hemisphere. But in the northern hemisphere, due to the dominance of landmass, it is broken, it is broken. Full stop. A permanent low pressure belt, a permanent low pressure belt in the northern hemisphere is found only at Aleutian low and Icelandic low. Icelandic low is found only at Aleutian low and Icelandic low. Finished? Now what does it mean? It means that in the northern hemisphere, during the winter season, as the snowfall starts, due to extremely cold temperature, वो पूरा region, subpolar low pressure belt वाला region also gets converted into high pressure, polar high pressure because of a heavy snowfall, except at Aleutian Islands. So where are these Aleutian Islands? Aleutian Islands are nothing but, if you remember, we always make North America like this. These are Aleutian Islands. Because there is more of a maritime influence, sea का influence, and Alaska warm current, यहाँ पे snowfall नहीं होता. So this remains a low pressure. And Iceland, Greenland के पास, because of Norwegian current, this remains a low pressure. Fine. Southern hemisphere में it is a permanent low pressure belt, a continuous line. If you remember yesterday's lecture, isotherms and isobars are more or less continuous. यहाँ पे here it becomes Aleutian low and Icelandic low. बाकी का disappears. बाकी का region में, if you remember current affairs, there is so heavy snowfall कि blizzard blows in this region. There is a cold waves in USA. Cold waves means obviously temperature decreases and it gets converted into high pressure. So what you have to remember, even in GS, it is given in NCERT also, your 11th standard, the subpolar low pressure belt is discontinuous in northern hemisphere. It is continuous in southern hemisphere. Why it is discontinuous? Because it disappears during the winter season from all the regions except Aleutian Islands, therefore it is known as Aleutian low, and Iceland, Greenland region, therefore it is known as an Icelandic low. Bas. Getting it? In QAP also I had stressed this point, prelims ka QAP, if you remember or no. So, you were also in QAP? I had stressed on this point and a past year question भी discuss किया था, इसी से related. Next, polar high pressure belt. Is found consistently throughout the year. Is found consistently throughout the year in the polar regions. Consistently throughout the year in the polar regions. Full stop. Caused by subsidence of cold airs, caused by subsidence of the cold airs, from above, the subsiding air then flows on the surface as the subsiding air then flows on the surface as cold polar easterlies. Flows on the surface as cold polar easterlies. cold polar easterlies. Cold polar easterlies. Winds which come from east are easterlies. Understood? I am going bit technical, सिर्फ समझो, बाद में मुझे ज़रूरत पड़ेगी इसमें. यहाँ से air is descending, therefore ground पे there is a high pressure. यहाँ से polar easterly is ascending, westerly is ascending, यहाँ पे ground पे there is a low pressure. Wind always flows from high pressure to low pressure, and due to Coriolis force it will be deflected to the east. And because it is coming from the poles, we are calling it as cold polar easterlies. Fine? But यहाँ से निकल रही है winds, यहाँ से air नीचे आ रही है. So tell me, will there be more air here or will there be less air here in the upper atmosphere over the poles? Less air. Tell me if you don't understand. Air is coming downwards, so can I say there is a thinning of the air in this region? Getting it? Air is going upwards, so can I say there is a piling up of the air in this region? Air जब pile हो जाती है तो air जब thin हो जाती है तो low pressure. So upper air, understanding? तो समझ में आया ये? So जहाँ जहाँ ground पे there is a high pressure, at the upper air there will be low pressure. जहाँ जहाँ ground पे there is a low pressure, upper air there will be high pressure. So this results into thinning of an air, low pressure conditions. This thinning of an air sometimes directly settles down. But nowadays, due to global warming, these regions are becoming very, very warm. जो यहाँ पे summers में temperatures, winter में temperatures होना चाहिए था, it has become very warm. If you remember in our discussion, polar regions and tropics are going to face the global warming. These are becoming very, very warm. And because this becomes very, very warm, ये air जो नीचे जानी चाहिए, it gets attracted even till here, which should go straight downwards. Where it gets attracted, some part goes straight downwards, some parts comes in this region, and इसी को हम कहेंगे which started happening from this year in North America. Getting it? Polar vortex event. Air is getting attracted. The air which should go straight down, but वो देखता है अरे low pressure is there even in the temperate regions, because जितना ठंडी में वहाँ पे it should be the average cold which should have been maintained in that region, that is not there because of global warming. So this air starts going towards even that region, and this is what is known as a polar vortex event, and this is extremely cold air. जब वो आएगी in the temperate latitudes, it obviously will freeze, bring the freezing temperatures, and therefore there will be heavy snowfall. अब जितना ये air यहाँ से नीचे जाएगी, उतना stronger this air will come towards here. जितना the stronger air comes towards here, उतना stronger will be the polar vortex event. And sometimes, understanding everyone, sometimes this polar vortex event when they descend, because ये पूरा ठंडा है, so this air when it descends, ये आएगी through this gap, and it will result into Noida, Delhi का abnormal temperature in winters this year. There was so heavy snowfall in Noida. There was hailstorms in Delhi, January this year. This all is related to USA में जब होता है, then it is known as polar vortex event. India में जब होता है, then it is known as extremely strong western disturbance. Nothing. Mechanism is same. mechanism is same. कोल्ड एयर क्यों आ रही है इस रीजन से, हिमालयास के बाद में गैप है बिटवीन सुलेमान एंड किरतार रेंजेस विच इज नोन एज खाइबर पास रीजन, एंड दैट इज इनफ फॉर सरफेस विंड्स टू कम टुवर्ड्स इंडिया. गेटिंग इट? So whenever you read in the newspaper कि there is a thinning up of the air is occurring etc, याद रखना सर ने तो कहा था कि हाई प्रेशर है, न्यूज कह रहा है कि थिनिंग हो रहा है एयर, they are referring to this part. Fine. So due to global warming thinning is increasing, they are referring to this part. What? Which one? This one, polar vortex. Polar vortex is nothing but increase in the cold polar air which should descend here. It is coming towards the lower latitudes. Why it is coming towards the lower latitudes? Just because koi bhi air flows from high pressure to low pressure. So this air which should descend here will get attracted towards here. Why? Because ये ज़्यादा गर्म है as compared to this. So ये बन जाता है high pressure, ये बन जाता है low pressure. We will come to this again. ये हम technically करेंगे polar vortex events. This is just an idea कि क्या हो रहा है polar vortex events. Fine with the pressure belts. Winds, easy topic except jet stream or sub. See, when we say the winds, we divide the winds into three parts. Some of the winds are known as primary circulation or planetary winds. Planetary winds. Why planetary winds? Because they blow all along the planet, anywhere. So what are the planetary winds? ये जितने भी winds हमने की है, these are an example of planetary winds. They blow all along the planet in the form of trade winds, westerlies, easterlies. These are the planetary winds. And this is also known as an primary circulation or winds of first order. When some primary winds are modified at a regional level, some primary winds will be modified at the regional level. Trade winds का direction change हो जाएगा, वो equatorial westerlies बन जाएगी या southwest monsoon winds बन जाएगी due to the shift of ITCZ etc. They are known as seasonal or secondary circulation. And इसमें हमारा example is monsoon winds. So that is why इसी के साथ साथ we'll do the Indian monsoon only when we do the monsoon winds. Fine. And the third wind, which is land and sea breeze, which are caused due to local level changes. It has nothing to do with the planetary winds etc. They are known as local winds. Or they are known as tertiary circulation. Example इसमें there will be some winds, and tertiary circulation is most important for GS. ऑप्शनल में इतना ये नहीं, जितना जीएस में पढ़ते हैं उससे भी लिख सकते हो आप. चिनुक, फॉन, सिरोक्को, मिस्ट्राल, बोरा, हरमटान. These are the examples of the local winds. Winds of first order का example is trade winds, westerlies, and easterlies. And easterlies. Very simple topic if you understand. Very difficult topic if you don't understand. Winds. Now, ये words आए, westerlies, easterlies. What are this? This is nothing but जिस direction में wind is originating, we give it the name. If it is originating from west to east, it is westerly. If it is originating from east to west, it is easterly. Fine. It does not matter whether it is a surface wind, whether it is a local wind, etc. Westerly मतलब west to east आ रही है. Westward मतलब west की तरफ आ रही है. Westerly means it is flowing from west to east, not westward. Westward means it is going towards west. Westerly means it is going towards east, from west to east. So कहाँ पे originate हो रही है? West. Easterly means it is originating in the east. That is why we said polar easterlies, because it is originating from northeast to southwest. We say southwest monsoon is equatorial westerlies. Why? Because they come from west to east. Getting it? And based on this, सबसे पहले direct questions here. What are the different factors affecting winds? Though I will give it, but अगर time मिला तो I'll try to give you Xerox only of this in the next class. There are two booklets, Made Simple series का, रूपा publication का. So they are basically known as रूपा Made Simple. अगर उनके authors का नाम लिया तो कोई book वाला कहेगा ऐसी book नहीं है हमारे पास. उनको जब बोलोगे कि रूपा Made Simple चाहिए, तो they will give you two booklets. One is of human geography, one is of physical geography. You have PDF, so you share it. Clear hai PDFs? Except there is no content. Means? Acha. This. No, I know the pages. I'll just share the pages there. Then no need of buying physical or human. If he has the PDF, I'll give you the required pages, because it becomes easy to take print out rather than giving the book for Xerox. Fine? So what are the different factors affecting wind? One is the pressure gradient force. That is the rate of change of pressure. I'll quickly tell you first. That is, wind always flows from high pressure to low pressure. and the pressure gradient force acts from high pressure to low pressure, and therefore wind flows from high pressure to low pressure in this direction. That means if this is the equatorial low pressure belt, wind should flow from the subtropical high pressure belt towards the equatorial low pressure belt, from subtropical high pressure belt to the equatorial low pressure belt, from subtropical high pressure belt to the subpolar low pressure belt, from the subtropical high pressure belt to the subpolar low pressure belt, and from polar high pressure belt to the subpolar low pressure belt in this manner. Fine. That is, can I say wind always flows perpendicular to the isobars? Pressure gradient force में wind always flows perpendicular to the isobars. अगर बाकी के conditions don't exist, then only. But there are some other conditions that exist. That is the rotation of the earth. And because the rotation of the earth, फिर से सुनो. So can I say this is the direction of the pressure gradient force, that is from high pressure to low pressure? Right? Wind always flows from high pressure to low pressure. Take this example. Forget बाकी का examples. But कोई भी wind ऐसे straight नहीं जाएगी, because due to the rotation of the earth, there is an imaginary force which applies perpendicular to the pressure gradient force, and this force is known as Coriolis force. This is the pressure gradient force. So wind flows from high pressure to low pressure, but because the earth is rotating from west to east, any object on this rotating earth is deflected to the right in the northern hemisphere, is deflected to the left in the southern hemisphere. Getting it? कहाँ पे ज़्यादा हो रहा है deflection? Equator के पास या poles के पास? Poles के पास. Because the Coriolis force is inversely proportional to the rotational speed of the earth. Since the rotational speed of the earth is maximum near the equator, कैसे लगेगा rotational speed of the earth maximum at the equator? It is very simple. You have to look at the earth from this angle. If the earth is rotating, and if this is covering the entire rotation, if this place which is located at the equator is taking, after 24 hours, it is completing one circle. Coriolis force is maximum at the poles. Rotational speed of the earth is maximum at the equator, and therefore Coriolis force is inversely proportional to the rotational speed of the earth. Now you see here, look at this angle. If any place on the equator, after 24 hours, it will come back to its original position. Fine? So if this is the earth, and this is the place on the equator, if we take this place A, after 24 hours, it will come back to its original position. Take any place near the poles. After 24 hours, this place B will come back to its original position. इसको भी 24 घंटे लग रहे हैं, 24 hours. This is also going to take 24 hours. Which place is covering greater distance, place A or place B? Place A is covering the greater distance. If we take the top view of the earth, not the side view. Side view, say you won't understand the Coriolis force. Place A is covering the greater distance. Place B is covering the lesser distance. That means, can I conclude that place A is moving at a great speed as compared to the place B? Therefore, we say the rotational speed of the earth is greater over the equator and lesser over the poles. Fine? So if understood this? So if a person wants to go from poles to the equator, if a person wants to go from poles to the equator, and which is moving at a greater speed? Place A. So person cannot go in a straight line, because now it is moving. Person, if it goes in a straight line, place A to आगे निकल गया. So a person will have to get deflected to the right hand side. So we say Coriolis force के कारण anything gets deflected to the right hand side. समझ में आया? If a person wants to go from place C to place D, imagine it is rotating. अगर वो सीधा गया तो place D आगे निकल जाएगा, because it is rotating at a great speed. So person will have to get deflected to the which hand side? Left hand side. Direction of arrow देखो. This is what is the Coriolis force. So that is why, and if a person wants to go from place A to place D हो गया E, और place D to place F, उसको डिफ्लेक्शन करने की जरूरत है, या प्लेस E से उसको A के पास जाना है, he may go more or less straight. प्लेस F से D के पास जाना है, he may go more or less straight, because यहाँ पे पूरे रीजन में रोटेशनल स्पीड इज हाई. Therefore we say Coriolis force is now a person wants to go from place A to place B, from place A to place B, or from place F to place C. It will obviously move as per the northern and southern hemisphere. मतलब उसको left या right में जाना पड़ेगा, but if you try to understand the Coriolis force from this angle, कभी नहीं समझ में आएगा. For the Coriolis force, you will have to look at this angle of the rotation of the earth. Getting it? You will have to look from this angle. Coming to our statement here. Now when we are considering the winds, I will come to the Coriolis force फिर से. First let us understand what is this winds. Because pressure gradient force wind को इस direction में खींच रहा है, Coriolis force wind को इस direction में खींच रहा है, so इन दोनों के बीच में wind जाएगी and the wind will get deflected to the in this, and therefore any wind, pressure gradient force is here, Coriolis force is here, so the wind will get deflected to the right hand side. Coriolis force is here, pressure gradient force in the southern, pressure gradient force is here, in the southern hemisphere Coriolis force is in the left. इस side मत बनाओ, and therefore the wind will get deflected to the we will call this winds as easterlies. The knowledge of this wind was very much necessary for colonial powers and for the trades. England से if you don't know this wind, you will land up in South America. पर आपको आना है इंडिया एंड चाइना, आप चले जाओगे साउथ अमेरिका में, आप चले जाओगे सेंट्रल अमेरिका में, जो कोलंबस के साथ हुआ था. Columbus never discovered USA, I told you that earlier. He discovered Central America. Fine? And because the knowledge of this wind was very much necessary, we will call easterlies as trade winds. As trade winds. No need of this diagram, just try to understand here. Pressure gradient force is acting in this direction, Coriolis force to the right hand side of this, and therefore winds to the left hand side of this, and therefore the winds and we will call this winds as westerlies. Coming to oceanography, as the westerlies go to the southern hemisphere, उनका speed increases. They are known as roaring 40s, furious 50s, streaking 60s. उनका speed increases. As उनका speed increases, deflection increases. और ये बन जाती है geostrophic winds. I'll come to that. Oceanography में हमने देखा west wind drift. Fine. And lastly, using the same logic, easterlies. To avoid the confusion, because it is moving from east to west, to avoid the confusion, we call this as polar easterlies, because there is one more easterlies. Coriolis force आप आराम से देख सकते हो. टेक अ CD if you have at your house, घुमाओ उसको और उसके ऊपर स्केच पेन रखो. It will either get deflected to right or to left. Northern hemisphere में है, you will see deflection mostly to the right. Take that CD some time in your life in southern hemisphere and see the deflection, it will be to the left. Fine. So one is there are two forces. Have you understood the two forces? Pressure gradient force and Coriolis force. But this is not the only force. There is one more force. Which acts only on the surface winds. पीछे इसलिए because it reduces the speed of the surface winds. It reduces the speed of the surface winds. So ये तीन major forces. Getting it? चलो कोई नहीं. Is it visible? Low pressure, surrounding high pressure. Cyclones in northern hemisphere, low pressure, cyclones in southern hemisphere. Can I say this is anti-clockwise and this is clockwise? Right? This is anti-clockwise, ऐसे घूम रहा है. Sorry, this is clockwise and this is anti-clockwise. ऐसे घूम रहा है and ये ऐसे घूम रहा है. This is in northern hemisphere. This is in southern hemisphere. Tell me the reason. Coriolis force applied. ये तो राइट में जा रहा है, लेफ्ट में जा रहा है. This is clockwise in the southern hemisphere. This is right. That is anti-clockwise in the northern hemisphere. Coriolis force says the winds will get deflected to the right hand side in the northern hemisphere, but the cyclones तो southern hemisphere में right hand side जा रहे हैं, left hand side जा रहे हैं. Right? ऐसे क्यों हो रहा है? This is the fifth factor. कभी कभी ऐसे समय मेरे को ऐसे मन करता है वेलकम टू ज्योग्राफी ऑप्शनल बोलने, राइट? दिस इज व्हाट इज द ग्रेडियंट विंड. अब यू विल अंडरस्टैंड क्यों डरते हैं लोग आफ्टर डेविस एंड पेंक फ्रॉम दिस ऑप्शनल. ये एक और वैसा ही फैक्टर है, बिकॉज ग्रेडियंट विंड डिपेंड्स अपॉन फ्रिक्शनल फोर्स, कोरियोलिस फोर्स एंड प्रेशर ग्रेडियंट फोर्स का डायरेक्शन. सो पहले इजी वाला पार्ट, राइट? दैट इज अगेन सिंपल कोरियोलिस फोर्स इन एक्शन. एक बार खत्म होने के बाद यू विल अंडरस्टैंड दिस. I guess you had this question somewhere in the recent years itself. Open your past year questions and look at 2017 ka paper. This is nothing but, in difficult language, the factors that affect the winds. That is, discuss the forces which govern the air movement on the earth's surface. Kuch nahi hai. It is just nothing but the factors that affect the wind. These are the 4 forces that govern the air movement on the earth's surface. फिर से wind में से question 2018. Origin, progress, retreat of Indian monsoon and discuss its impact on the Indian economy. फिर से wind में से question 2015. Every alternate year, can you see the trend? Explain the meridional circulation of the atmosphere and its importance on the world climate. The way we have drawn tropical cell, Hadley cell and the Ferrel cell. फिर से 2014 में question. Discuss the nature and the origin of Indian monsoon and the recent techniques of its prediction. El Nino, La Nina, Indian Ocean Dipole. These are the recent techniques. 2014 में फिर से question. Discuss the salient features of Sirocco and Mistral. एक temperature inversion में से question. Discuss dew point and various forms of condensation. फिर से question, with the suitable examples, bring out the impact of local winds on the climate of an area. 13 में repeat, 14 में repeat. Wind से 11 में question, write a short note on the Rossby waves and jet streams. Frontogenesis पे question, what is polar front, how does a cyclone develop in the regions of a polar front, discuss the weather conditions associated with it. Write a short note on the inversion of temperature. Write a short note on atmospheric instability. How does climate change affect the urban areas? फिर से climate change, etc. फिर से 2007 में question, 2008 में question, local winds monsoon पे. 2003 में question, tricellular meridional circulation पे. So I am not going much behind, but you can see areas बहुत specific है. Except for Köppen and Thornwright, anybody with GS also can write these answers. Climate change, winds, factors affecting winds, temperature inversion. So that is why to you to get selected in climatology, मैं बार-बार कहूँगा, don't see geomorphology जो पढ़ाई नहीं करता वो नहीं लिख पाएगा. Fine? जो ऑप्शनल प्रॉपरली नहीं करके जाएगा वो जियोमॉर्फोलॉजी नहीं लिख पाएगा. सो ही विल टारगेट ह्यूमन ज्योग्राफी एंड क्लाइमेटोलॉजी. सो टू एंड देयर आर सम पीपल हु विल हैव द हैबिट ऑफ टेकिंग वेरी हाई मार्क्स इन जीएस 403, 404, 450. उनको कंपटीशन से दूर रखने के लिए आपका एक ही सहारा है, जियोमॉर्फोलॉजी. बिकॉज जियोमॉर्फोलॉजी इज वन सच टॉपिक, व्हेन यू अटेम्प्ट दैट क्वेश्चन you get maximum marks. Fine? You see your own reaction. When you were doing geomorphology, ऐसा लग रहा था सब कुछ नया है. When we started with climate and ocean, अरे ये तो GS में भी पढ़ा है, ये GS में भी पढ़ा है. The same examiner will go through the same this thing. Wow, he understands geography. So coming to winds. Winds is defined as horizontal movement of air according to Bayer, B-Y-E-R, wind is air in motion Wind is air in motion, usually measured only in horizontal component. Usually measured only in the horizontal component. Usually measured only in the horizontal component. Matlab only the horizontal movement of the air is known as wind. This is, so if you know bare का definition of wind, you know factors affecting movement of air, मतलब इन्होंने यही कहा है. Fine. Conclusion में आप लिख सकते हो कि convection and subsidence also affects the governance factors. Wind is simply the air in motion, usually measured only in its horizontal component. I am giving the definition verbatim. You can write it in your own language. According to Bayer, horizontal component of air in motion is known as wind. Or according to Thevartha, the father of climatology, according to Thevartha, wind is an air moving in direction. Wind is air moving in direction which is essentially parallel with the Earth's surface. Which is essentially parallel to the Earth's surface. तो अर्थ सरफेस को कौन सा पैरेलल होगा? हॉरिजॉन्टल या वर्टिकल? हॉरिजॉन्टल. सरफेस पे सरफेस विंड्स, अपर एयर पे एंटी ट्रेड्स या जेट स्ट्रीम्स. सो बट इन दोनों में से एक डेफिनेशन आने देना. द एयर मूवमेंट आर ऑफ टू टाइप्स. Vertical air movement known as currents is due to heating and cooling causing up drafts and down drafts. Up drafts and down drafts respectively. Updrafts and downdrafts respectively. Heating से updraft, cooling से downdraft. Clear? Next. While the horizontal movement of the air is due to one, horizontal pressure gradient force. B, due to Coriolis force. C, due to frictional force. एंड जो मैं साइक्लोन्स का बता रहा था, ड्यू टू centrifugal force. So what are the 4 factors that govern the air motion? These are the 4 factors: pressure gradient force, Coriolis force, frictional force, and centrifugal force. Centrifugal force means towards the center, yeah, away from the center, away from the center. Fine. And centripetal means towards the center. Don't draw anything, just tell me. What does it mean? बाहर हाई प्रेशर है, अंदर लो प्रेशर है. So which direction में Coriolis, किस डायरेक्शन में प्रेशर ग्रेडियंट फोर्स विल अप्लाई? Outside to inside. In which direction centrifugal force will apply? Centrifugal force is always towards the center. किस डायरेक्शन में Coriolis force will apply? Perpendicular to the pressure gradient force. This is pressure gradient force, this is centrifugal force. So wind आएगी, Coriolis force उसको राइट को मुड़ने के बदले वो इस डायरेक्शन में मुड़ेगी, वो सेंटर की तरफ जाएगी. फाइन. ये विंड इस डायरेक्शन में मुड़ेगी, सेंटर की तरफ जाएगी. Right hand side in the northern hemisphere to the pressure gradient force, always to the right of the pressure gradient force, and then center की तरफ मुड़ेगी and ultimately circulation बन जाएगा anti clockwise. That is right. If it is not visible, what? Towards the center. Centrifugal means, centripetal is, I am sorry, मैं फिर से confuse हो गया. I am very sorry. फिर ये right कैसे हुआ? Sorry, this should have been high pressure. Taken 2 examples here. There is a low pressure and surrounding this is an high pressure. In this low pressure systems, this is the direction where the, what is acting? Pressure gradient force. This is the direction where centrifugal force is acting. If it is in the northern hemisphere, then is direction Coriolis force will act. If it is in the southern hemisphere, then is direction Coriolis force will act. Similarly, in the cyclones, this is the direction where the pressure gradient force is acting. This is the direction where the centrifugal force is acting. And pressure gradient force के right hand side में what will act? Coriolis force. Left hand side में what will act? In the southern hemisphere, Coriolis force. With this 2 points, when the wind is up, wind में all these forces are getting applied, हम इसको कहेंगे as gradient wind, which is जिसका example is anticyclones and cyclones. When these three forces are acting when only two forces are acting, we will call this as geostrophic winds. Understanding? जब तीनों फोर्स एक्ट कर रहे हैं नॉर्मल विंड्स, जब चारों फोर्स एक्ट कर रहे हैं देन ग्रेडियंट विंड, एंड सिर्फ जब दो फोर्सेस एक्ट कर रहे हैं तो जियोस्ट्रॉफिक विंड्स. जियोस्ट्रॉफिक winds are caused due to the balance of the pressure gradient force and the Coriolis force. Normal wind is acted upon generally by the horizontal pressure gradient force, Coriolis force and the frictional force. But kabhi-kabhi when the low pressure or the high pressure centers are developed, low pressure and high pressure centers are developed. Low pressure center in the terms of cyclones, high pressure centers in the terms of anticyclones. Then there is a new force that either will pull the wind towards the center, will pull the wind away from the center, and the final direction of the wind will be determined by the interaction of centrifugal force, whether it is acting in the same direction as the pressure gradient force, or centrifugal force, whether it is acting in different direction as the pressure gradient force, and Coriolis force. Frictional force may not play an important role because jitna zyada differences between the high pressure and the low pressure, utna greater is the wind speed. Jitna greater is the wind speed, utna lesser is the frictional force. Getting it? Geostrophic winds is Coriolis forces direction mein hai, sorry, pressure gradient forces direction mein hai, Coriolis forces direction mein hai. Frictional force absent hai. So Coriolis force tries to balance the pressure gradient force. As the Coriolis force tries to balance the pressure gradient force, wind instead of moving straight starts to flow parallel to each other. We'll come to this, ye char cheeze hai. So that is why it is bit technical sometimes. Horizontal pressure gradient force, high pressure to low pressure. So can I say wind flows perpendicular to the isobars due to the pressure gradient force? So there are 2 points here. Before I begin, tell me, is it a wind deflecting force, pressure gradient force, or wind generating force? Yeah, dono. Wind always will flow from high pressure to low pressure. If there is no high pressure or low pressure on the land, there will be no wind. So what is this now? Wind generating force. And obviously direction to determine karega. So first, pressure gradient force. Pressure gradient force is the force that causes wind movement. Is the force that causes wind movement. Force that causes the wind movement. इसलिए wind generating force. Next, wind always flows from high pressure to low pressure. Wind always flows from high pressure to low pressure. याद रखना, gradient means rate of change or difference. Technically it means rate of change. Not कि यहाँ पे कितना high pressure है, यहाँ पे कितना low pressure है. It means कितना high pressure to low pressure कैसा change होते जा रहा है. अगर change बहुत ज़्यादा है, that is ये अगर high pressure है और ये अगर low pressure है, change बहुत ज़्यादा है. So if I want to draw a mountain, this will be how the slope of a mountain will be, right? If the change is not great, this is high pressure, and if this is low pressure, and if I want to draw a mountain, this is how the mountain will be. Rate of change, it is not just the difference between high pressure and low pressure, it is the rate of change. Fine? इसलिए ये diagram, we will see this diagram is used in the cold front and warm fronts, like this triangle. Understanding? It is We draw a triangle or a mountain. So jitna zyada slope, utna greater is the speed of the river. Gradient is slope gradient. Jitna kam slope, utna less is the speed of the river. इसलिए greater the pressure gradient, greater is the wind speed. Lesser the pressure gradient, lesser is the wind speed. Fine? Next. Pressure gradient determines wind direction, high pressure to low pressure, as well as wind velocity. Wind direction and wind velocity. Greater the pressure gradient, wind direction and wind velocity, greater the pressure gradient, higher is the velocity. Higher is the velocity, and vice versa. And vice versa. In the map, spacing of isobars is used to determine the pressure gradient. Tell me, closely spaced isobars, widely spaced isobars, किसमें pressure gradient ज़्यादा? Closely, 10 millibars, 20 millibars, 30 millibars, 10 millibars, 20 millibars. Fine? इसलिए widely spaced. मतलब in entire this region, till this region is 10 millibars. उसके बाद will be 20 millibars. यहाँ पे 10 to 20 is only this. बाकी का region is 20 to 30. So closely spaced isobars means steep pressure gradient. Understand why we use the word steep instead of high. दोनों use कर सकते हो. Steep because we make a mountain. Means steep pressure gradient. And therefore higher wind velocity. Higher wind velocity. Next, wind direction is always perpendicular to the isobars. Wind direction is always perpendicular to the isobars. Wind direction is always perpendicular to the isobars. Next, Coriolis force. Coriolis force. An imaginary force that is caused due to the rotation of the earth. It is caused due to the rotation of the earth, and which has effect on every moving object, not on the stationary object. अगर आपको यहाँ से यहाँ जाना ही नहीं है तो Coriolis force won't act. It will act only if you want to move from here to here, which has effect on every moving object. Is known as Coriolis force. Before I go, technically क्या होना चाहिए? Coriolis force या कोरियोलिस इफेक्ट, व्हाट इज द राइट वर्ड? टेक्निकली देयर इज नो सच फोर्स, ये इमेजिनरी इफेक्ट है। ये अगर अर्थ रोटेट हो रहा है एंड बिकॉज द आउटर स्पीड इज ग्रेटर, तो मुझे मिसाइल प्लेन्स किस डायरेक्शन में लेके जाना है। फोर्स मतलब कोई एक्सटर्नल ऑब्जेक्ट मूव नहीं करा रहा है, हम ऐसा सोच रहे हैं कि हमें इस डायरेक्शन में मूव करना है। एंड जब हम प्लेन्स कोरियोलिस इफेक्ट के हिसाब से चलाते हैं तो वी लैंड एट प्रॉपर डेस्टिनेशन। व्हेन यू डोंट अप्लाई द कोरियोलिस इफेक्ट टू प्लेन्स और मिसाइल्स, वो किसी और डायरेक्शन में निकल जाते हैं। सो एक्चुअली इट इज नॉट अ फोर्स, इट इज जस्ट एन इफेक्ट। इसलिए हमने वर्ड यूज किया है इमेजिनरी। फाइन। This effect results from rotational, results from difference in the rotational speed of the earth, difference in the rotational speed of the earth full stop. The Coriolis effect is inversely proportional to the rotational speed. Is inversely proportional to the rotational speed. And as the rotational speed is greatest near the equator, rotational speed is greatest near the equator, we can say that Coriolis force is zero or minimum near the equator. Zero or minimum near the equator. मैं GS में कहता हूँ at the equator zero, in the equatorial regions minimum, 5 degree north to 5 degree south it is minimum. Next. इन्वर्सली प्रोपोर्शनल मतलब जितनी रोटेशनल स्पीड इंक्रीज होगी उतना कोरियोलिस फोर्स कम होते जाएगा। तुम दो चीजें कंफ्यूज कर रहे हो। हम कह रहे हैं ये रोटेशनल स्पीड ऑफ द अर्थ है, इसके अपोजिट है कोरियोलिस इफेक्ट। राइट? कोरियोलिस इफेक्ट मतलब कितना डिफ्लेक्ट होने वाला है कितना नहीं, एट द इक्वेटर और एट द पोल्स। से इक्वेटर पे अर्थ इतना फास्ट घूम रहा है कि इस प्लेस से इस प्लेस में आने के लिए डिफ्लेक्शन की ज़रूरत नहीं है, बिकॉज ऑल दिस रीजन्स विच आर नियर द इक्वेटर, दैट इज 0 to 5 degree north and 0 to 5 degree south, that is from A to B, you don't have to get deflected. So we say Coriolis effect is minimum, but difference in the rotational speed is at the poles. So if you are moving at A with higher speed and the C का person is moving at lesser speed, so from A to C आने के लिए you will have to get deflected. So because the rotational speed of the earth is lesser near the poles, you can see deflection बहुत ज़्यादा है. Because it is near the equator, rotation deflection कम है. तुम जो पूछ रहे हो वो है wind velocity and the Coriolis force. जब velocity of any horizontal object is greater, then deflection is greater. वो एक अलग factor है. Don't confuse the two factors. These are Coriolis force. अर्थ पे कहाँ पे ज़्यादा होगा? At the equator, देखो डिफ्लेक्शन की ज़रूरत ही नहीं. Poles, देखो डिफ्लेक्शन की ज़्यादा ज़रूरत है. This is what is meant by the statement. Understanding? Zero or minimum near the equator. याद रखना ये चीज़ें. इसीलिए हम कहते हैं डिफ्लेक्शन होगा ही नहीं of the winds near the equator, and because of lack of deflection of the winds near the equator, tropical cyclones will not originate. For example, equatorial regions are very, very hot. So there will be a low pressure centers at the equator. But tropical cyclones के लिए अभी आपने देखा क्यों हो रहा है, forget about it. But अभी आपने देखा wind has to get deflected towards the low pressure center. Winds have to get deflected. Winds have to get deflected. But near the equator winds deflect ही नहीं होगी. क्यों? क्योंकि Coriolis force है. वो सीधी चली जाएगी. And therefore विंड का स्पीड मत सोचो कोरियोलिस फोर्स के साथ, अर्थ के रोटेशनल स्पीड के बारे में सोचो. विंड जनरेट हो रही है ड्यू टू हाई प्रेशर एंड लो प्रेशर. अर्थ अगर रोटेट हो रहा है तो विंड ऐसे जनरेट होनी चाहिए थी. ऐसे क्यों हो रही है? ऐसे क्यों हो रही है? अर्थ का रोटेशन क्या है? वेस्ट टू ईस्ट, राइट? ऐसे है. विंड ऐसी है या सारी विंड्स ऐसी है? फाइन. इट हैज नथिंग टू डू विद अर्थ का रोटेशन. winds have nothing to do with earth का rotation. Winds are simply caused due to high pressure and low pressure. Winds are deflected due to Coriolis force. मैंने आपको Coriolis force में ये नहीं लिखाया है, it is a wind generating force. Wind generating force is only the pressure gradient force. Getting it? It is wind deflecting force. कितना deflect होगा depends upon, no, again you are confusing. कितना deflect होगा, winds will depend upon whether the wind is near the equator 0 to 5 degree or in the poles 65 degrees to 90 degrees. यहाँ पे rotational speed कम है अर्थ की, यहाँ पे rotational speed ज़्यादा है अर्थ की. Fine? रोटेशनल स्पीड का और प्रेशर ग्रेडियंट फोर्स का लेना देना ही नहीं है. ज्यादा होगा. इसका डाउट इज वेरी कॉमन. डाउट ये है कि जहां पे विंड का स्पीड ज्यादा है वहां पे कोरियोलिस फोर्स ज्यादा लगेगा. वेरी राइट. If the velocity is greater, then deflection is greater. Fine? But deflection होगा कि नहीं, ये डिपेंड करेगा even on the rotation of the earth. सिर्फ velocity के ऊपर नहीं. और दूसरी क्वेश्चन जो तुम्हारा है, विंड की velocity इक्वेटर पे ज़्यादा है या कम है? विंड्स है ही नहीं इक्वेटर पे. That is why it is the belt of doldrums. Getting it? विंड्स है ही नहीं. कभी कभी विंड्स है इक्वेटोरियल वेस्टर्लीज. विंड्स आर नॉट देयर. दिस इज अ वेरी कॉमन डाउट बिकॉज ये सबसे कंफ्यूजिंग है. हम कहते हैं कि रोटेशनल स्पीड, कोरियोलिस फोर्स ज्यादा है तो स्पीड ऑफ द विंड इज ग्रेटर. नहीं, स्पीड ऑफ द विंड इज ग्रेटर तो कोरियोलिस फोर्स इज ग्रेटर. हाँ. सो इसका दिस इज अ वेरी कॉमन डाउट इन स्टूडेंट्स. प्रेशर ग्रेडियंट फोर्स डिटरमाइंस विंड्स वेलोसिटी. Wind's velocity determines deflection. मतलब pressure gradient force will determine the speed of the wind. Speed of the wind will determine the deflection. If the speed is greater, deflection is also greater. But deflection is also determined by one more factor, is latitudes. Understanding? It has nothing to do with the speed. Latitudes में it is determined अगर इक्वेटर के पास है तो मिनिमम डिफ्लेक्शन, अगर पोल्स के पास है तो मैक्सिमम डिफ्लेक्शन. Why? Because Coriolis force is inversely proportional to the speed of rotational speed of the earth. It is inversely proportional to the rotational speed of the earth. This factor and this factor are totally independent. What you are doing, you are confusing between these two factors. ये factor totally independent है, ये factor totally independent है. अगर इक्वेटर पे स्पीड भी बहुत ज्यादा है विंड की, फिर भी कोरियोलिस फोर्स जीरो ही रहेगा because dominant factor is rotational speed of the earth. If the rotational speed of the earth is greater, no deflection. If the rotational speed of the earth is very slow, deflection. It has nothing to do with the speed of the winds. Understanding? Your doubt will get clear in the next paragraph. Understanding this? Rotational speed of the earth is maximum near the equator, इसलिए Coriolis force is 0. इसलिए in spite the speed of the winds being greater, near the equator deflect ही नहीं होती, वो सीधी चली जाते हैं. And therefore, equator के पास कभी tropical cyclones will never originate. Getting it? Coriolis force is directly proportional to, अब समझ में आएगा his doubt. The Coriolis force is directly proportional to first, horizontal velocity of moving body. Horizontal velocity of moving body. Horizontal velocity of moving body means nothing but speed. So if speed is greater, then maybe deflection will be greater. Understanding? It is inversely proportional to the rotational speed of the earth. It is directly proportional to the horizontal velocity of a moving body. That moving body can be ocean current, that moving body can be wind, that moving body can be ballistic missile, that moving body can be plane, koi bhi. Understanding? Second, mass of the moving body. Mass of the moving body. And third, sign of latitudes. Sign of latitudes. इसका मतलब sin 0, 0 degree latitude, sin 90, 90 degree latitude, sin 20, 20 degree latitudes. 0 degree latitudes पे no deflection, 90 degree latitudes पे maximum deflection. Next point. Because of this, the Coriolis force, because of the Coriolis force in the bracket, ये भी रखना Coriolis force का दूसरा नाम Farrell's law is maximum near the poles, is maximum near the poles. Third point के साथ continuation में ये point है sign of latitudes के साथ, is maximum near the poles but is 0 at the equator. Is 0 at the equator. And last point, Coriolis force affects only direction. Coriolis force affects only direction. ये दिमाग में डाल दो, and not speed. Pressure gradient force, both direction and speed. Coriolis force only direction, but because it is proportional to the horizontal velocity of a moving body, अगर speed बढ़ा तो deflection बढ़ेगा. Understanding? समझ में आ रहा है? Coriolis force affects only direction, never the speed. Pressure gradient force affects both speed and direction, but Coriolis force is directly proportional to speed, and इसलिए speed बढ़ा तो deflection बढ़ेगा, speed कम हुआ तो deflection कम होगा. So speed बढ़ता है of westerlies, इसलिए surface layer is deflected 75 degrees to this of the oceans, but subsurface layer में friction ज़्यादा है, उसमें deflection कम होता है. उसके नीचे के लेयर में और deflection कम होता है, उसके नीचे के लेयर में और deflection कम होता है, and ultimately this results into यही तो हमने पढ़ा था, सरफेस लेयर मैक्सिमम डिफ्लेक्ट होता है क्योंकि डायरेक्ट विंड के स्पीड के साथ साथ हो जा रहा है. सब सरफेस लेयर इज नॉट मूविंग विद द विंड स्पीड, इसलिए उसका डिफ्लेक्शन कम है, नीचे के लेयर का और डिफ्लेक्शन कम है. सो टोटल वाटर मास गोस 90 डिग्री टू दिस. थर्ड, frictional force. Frictional force. Frictional force. Frictional force acts at or near the Earth's surface. At or near the Earth's surface and is confined only to few thousand meters. It is confined only to few thousand meters. मतलब it is not going to act on the after some 2000 or 3000 meters. It is confined only to few thousand meters. मतलब it is not going to act on which winds? Anti-trades पे act करेगा? नहीं. Jet streams पे act करेगा? नहीं. Next. Frictional force before writing, tell me, should I say changes the speed of the wind, slows the speed of the wind, and speed of the wind slow हो गई तो deflection कम होगा. So can I say frictional force not only affects the wind speed but also its direction? Deflection determines the direction. Speed कम हो गया तो deflection कम तो direction change. So the frictional force slows the wind speed and hence changes the direction. ब्रैकेट में याद रखना, फ्रिक्शनल फोर्स इसीलिए विल रिड्यूस द कोरियोलिस फोर्स. Frictional force will reduce the Coriolis force. Next point, frictional force is greater over the land because of irregularities and roughness. Frictional force is greater over the land because of irregularities and roughness, while it is lesser over the oceans. And therefore, in the southern hemisphere, wind direction, wind speed and deflection both increases. In the southern hemisphere, wind speed and deflection both increases. wind speed and deflection both increases. Wind speed and deflection both increases. Hence, any surface wind will be governed by all the three forces. Any surface wind will be governed by all the three forces. Will be governed by all the three forces, giving rise to the resultant wind direction. Giving rise to resultant wind direction. Giving rise to resultant wind direction as shown in the diagram below. Giving rise to resultant wind direction as shown in the diagram below. देखो, had there been no this line frictional force, तो Coriolis force would have acted perpendicular to the wind direction. But because of the frictional forces, these two forces become more or less perpendicular to each other, Coriolis force and frictional force, and it does not remain properly perpendicular to the pressure gradient force. So क्या होता है, if this is the point of contact, if this is high pressure 1020 millibars, and if this is low pressure 1000 millibars, this is the direction of pressure gradient force. This is the direction of frictional force. This is the direction of Coriolis force, and therefore the surface wind ka direction will be in this direction. क्योंकि ये तीनों रिजल्टेंट फोर्स एक दूसरे को मोर और लेस परपेंडिकुलर एक्ट करते हैं. प्रेशर ग्रेडियंट फोर्स का कभी डायरेक्शन चेंज नहीं होगा. कोरियोलिस फोर्स परपेंडिकुलर होगा प्रेशर ग्रेडियंट के, फाइन, बट फ्रिक्शनल फोर्स रिड्यूस करेगा कोरियोलिस फोर्स को, दैट इज डिफ्लेक्शन को. एंड इसलिए ये तीन फोर्सेस ऐसे एक्ट करेंगे. अभी नहीं समझ में आएगा, नेक्स्ट टॉपिक में समझ में आएगा डायग्राम. हाँ हाँ, तो प्रेशर ग्रेडियंट फोर्स एंड कोरियोलिस फोर्स ही रहेंगे अगर फ्रिक्शनल फोर्स जीरो है. हैव यू ड्रॉन दिस डायग्राम? फर्स्ट ड्रॉ दिस डायग्राम, आई विल टेल यू व्हाट इज दिस. नहीं, क्योंकि वो सिर्फ साइक्लोन्स एंड एंटी साइक्लोन्स में ही एक्ट करेगा. सेंट्रीफ्यूगल फोर्स अवे फ्रॉम द सेंटर, फाइन, अवे फ्रॉम द सेंटर. यहाँ पे सेंटर ही नहीं है, सेंटर नहीं है ना, ये आइसोबार है, स्ट्रेट लाइन्स है. सेंटर मतलब गोल. सो इसलिए सेंट्रीफ्यूगल फोर्स कहाँ एक्ट करेगा? व्हेन देयर इज अ लो प्रेशर सेंटर, साइक्लोन, और व्हेन देयर इज एन हाई प्रेशर सेंटर, एंटी साइक्लोन. कहाँ पे है सेंटर? वो सेंटर नहीं, वो पॉइंट है जहां से विंड जा रही है. अवे फ्रॉम द सेंटर एक्ट कर रहा है तो कौन से डायरेक्शन में? इस डायरेक्शन में, या इस डायरेक्शन में, या इस डायरेक्शन में. ये तीनों भी तो सेंट्रीफ्यूगल फोर्स जैसे ही तो काम कर रहे हैं. सेंट्रीफ्यूगल फोर्स कब काम करेगा? जब सेंट्रीपिटल फोर्स होगा तब, तभी काम करेगा ना सेंट्रीफ्यूगल फोर्स. सेंट्रीफ्यूगल इज अवे फ्रॉम द सेंटर. टेक एन एग्जांपल ऑफ वॉशिंग मशीन. सर्कुलर है, कपड़े डाल दिए आपने उसमें, जब तक मशीन चालू नहीं करोगे तब तक कपड़े वैसे ही रहेंगे. जैसे ही मशीन चालू करोगे, ड्रम विल स्टार्ट स्पिनिंग. एज द ड्रम स्टार्ट स्पिनिंग, देन सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्स ही एक्ट करना शुरू करते हैं. सेंट्रीफ्यूगल फोर्स कपड़ों को सेंटर से दूर खींचेगा, उसके बाद सेंट्रीपिटल कपड़ों को अंदर खींचेगा. कपड़े ऐसे 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 धुले जाएंगे. मशीन बंद करोगे, सेंट्रीफ्यूगल एंड सेंट्रीपिटल फोर्स ओनली एक्ट्स ऑन रोटेटिंग ऑब्जेक्ट. जब आप मेरी गो राउंड में जोर से घूमते हो व्हील में, गिरने का कभी डर नहीं होता, बिकॉज बोथ द फोर्सेस आर बैलेंसिंग ईच अदर. जब उसका स्पीड कम होता है तो फिर आपको गिरने का डर होता है, क्योंकि दोनों फोर्सेस गायब हो जाते हैं. अंडरस्टैंडिंग? सो कभी एक्ट करेगा जब कोई भी रोटेटिंग ऑब्जेक्ट है. साइक्लोन इज अ रोटेटिंग ऑब्जेक्ट, दिस इज नॉट अ रोटेटिंग ऑब्जेक्ट. इतना बड़ा लिखने से अच्छा एग्जाम में जस्ट राइट फैक्टर्स दैट गवर्न द एयर मूवमेंट. दिस जस्ट फॉर यू टू अंडरस्टैंड. आई हैव रिटन. वैसे एग्जाम के लिए आई विल कम टू दैट. क्या होगा व्हेन द फ्रिक्शन विल, आई विल कम टू दैट. तुम्हारा डाउट ये, अगर फ्रिक्शनल फोर्स कम होते गया एंड जीरो होते गया तो क्या होगा? आई विल कम टू दैट. हैव यू फिनिश्ड ड्राइंग दिस? Now his doubt is what will happen if the frictional force becomes zero. So there are three forces. Pressure gradient force का direction हमेशा same रहता है. It will always flow from high pressure to low pressure. It will not change with speed or anything. एक frictional force है, एक Coriolis force है. And therefore this is the direction of the surface winds. Now if the Coriolis frictional force becomes zero, then दो ही forces है. One is the frictional force, sorry, one is the pressure gradient force and दूसरा is the Coriolis force. And therefore ideally हमने starting में लिखा था Coriolis force will always act perpendicular to the pressure gradient force. So this should be the wind direction. But अब wind का speed बढ़ेगा. Wind will start going with more speed. Wind का speed बढ़ेगा तो wind का deflection increase होगा. As wind का deflection increase होगा, Coriolis force increase हो जाएगा. फिर से wind का जितना deflection speed increase होगा, उतना Coriolis force increase होते जाएगा, and ultimately there will come a time when the Coriolis force will be equal but opposite to the pressure gradient force, and in this case wind will flow parallel to the isobars, जिसको हम कहेंगे why? Because jet streams are generally 6 to 14 kilometers away from the ground, which means there is no frictional force. Understanding? The speed increases, Coriolis force increases. Speed increases, Coriolis force increases. It increases to such an extent that both the forces try to balance each other. Don't draw this. There is a separate topic, geostrophic winds. And this is not the diagram. Diagram is this is the actual diagram, 4 stages of geostrophic winds. So, but don't draw this diagram. It will come with each and every point. Point number 1, point number 2, point number 3, point number 4. Second example of a geostrophic wind is oceanography. Where it is? Polar region. North में या southern hemisphere में? Only southern hemisphere में. Because of the dominance of oceans, Coriolis force becomes 0. Centrifugal force. Centrifugal force is applicable only in the cases of circular isobars. These are the circular isobars. In the circular isobars, मतलब पूरा ये सेंटर हाई प्रेशर का है, पूरा ये सेंटर लो प्रेशर का है. अभी तक हमारे isobars were parallel, never circular. Only in the case of circular isobars. That is in the case of cyclones and anticyclones. And आगे लिखो, refer gradient wind. Refer the topic gradient wind. Fine? Gradient wind में ही apply करेंगे. So I'll stop here. Are you ready to come tomorrow? फिर मैं वीकडे में किसी एक दिन छुट्टी दे दूंगा. तो जब तक पीठ ठीक है मेरे को खींचने दो. एक दिन झटका तो लगने वाला है. बट स्टिल यू कैन सी अच्छे डॉक्टर को मिलने का फायदा इज within 3 days I am getting the effect. I should thank चैतन्य सर. अगर वो नहीं आते तो मेरी शायद टांग ही टूट जाती. I'll mail you.